The Cloud and DevOps session here in the afternoon. We have a very interesting talk right in the very beginning. Romain Gignardi from Awaystone will talk about going from monolithic to microservice, a journey I guess many of us have walked and also failed many times. So I'm looking forward to your talk. Thanks a lot.
Thanks. So, hi everyone. So quickly, I won't take a lot of time. I'm from a Western company and we are supporting our customer around digital transformation. And I've been working there for 10 years now. I've been working on the M&A topic, next gen IT transformation in Europe, US, Mexico, and now Singapore since 6 months for a large scale company. We start this speech by giving you a bit of feedback of the 2023 DevOps market. So in a nutshell, what I have seen so far is that my customers are saying it's a chaotic environment with a huge workload where the teams are always late and over budgets, and the releases are lacking quality and cybersecurity. In fact, when we are looking in depth, there are several topics that are emerging. So the delivery pace is an issue, meaning that the business wants to release a lot of releases on digital products, releasing new features, and the IT teams have some issue to follow that pace. The second part is regarding global consistency, and we can see that there are sometimes scope forgotten. There are operation and quality of services that are not at the right level, and same for the quality of the run. There are regression issue between the releases, etc. Regarding the target operating model and the delivery operating model, we can see that there are sourcing inconsistency between the team, between the delivery team, I mean. There are some sizing error in terms of strategic workforce planner in order to see, okay, I want to have 10 front-end developer, I want to have 2 back-end developer, and sometimes the capacity planning between the team are not the right ones. There are some poor separation inefficiency due to the legacy of IT organization created in the 90s. And finally, there are some budget management principles incoherence between the development team and the operation one. Regarding the sourcing strategy quickly, I've seen there are some inconsistency between the contracts, and there are some issue by asking your outsourced developer, for instance, to deliver faster because they have waterfall contracts. And here it's the most common issue that I've seen, and also the service level agreement part. Finally, there are the human resources and psychosocial hazards that we can face on your organization, on which that you have overload, turnover, and most common stuff that are coming now, and mostly on the Singaporean market, it's to keep and retain your talents in the company. In Western, we consider that there are 5 maturity levels that pave your way on the road to Agile and DevOps. So I will go quickly on that one because I think the DevOps part will be the next slide it must be focused on. So first level is the tailored one on which that everything is manually. So it's the one that you face like between the 90s and the 2000, sorry. The second one is the Agile project. So some of the application you started to develop it on an Agile way. Then there were the Agile application on which you started to push the dev and the ops working together. The Alliance, it's a bundle of application working all together in the Agile mode. And finally, innovation first, it's to let the biz work near the dev and the ops. But when we present that, the most common mistake that I can see is that when we are talking about DevOps, most of my customers are thinking about this first part. DevOps for most of our customers in Weston is only agile organization and collaboration culture. But in fact, DevOps is much more than that. It's for us, CI/CD pipeline, infrastructure as code, and application architecture are the cornerstones of the DevOps methodology. So everyone knows the agile organization and the collaboration culture because it has been brainwashed, and most common advisory consulting team are doing that. But the three other pillars are very interesting because you need to consider that to be able to have fast delivery, you must consider the infrastructure as code as part of it, meaning that you need to become an infrastructure code broker for your application in order to reduce as much as possible the time to market, the time to deliver any underlying platform and services from an IT standpoint. I will give you an example. For instance, how long do you wait to have a new virtual machine, a new VLAN to be created if you are working on the legacy services and not on infrastructure as code services? You need to ask a ticket on your ITSM, you need to wait for the team to be reassigned, and then you need to receive the service. With infrastructure as code, you aim to reduce as a service, meaning that it's click and you got the service right away. Regarding the CI/CD pipeline, it's the way to automate your code delivery from code repository toward your production in the fastest automated industrialized way. If we talk about DevSecOps, it's including also the security part on your CI/CD pipeline. Finally, the last pillar is the cloud native and modular application. So it's good to have the tooling. It's good to have the infrastructure as code. But if you have only have one big jar file, so one monolithic application, it's like asking an elephant to break your eggs in the morning. It's very efficient, but not accurate. So my point here regarding cloud native and modular application is the goal here is to work with the architect, to work with the business, to redesign your modular and microservices architecture in order to be scalable, in order to enhance the fact to push small features into your CI/CD pipeline, triggering infrastructure as code as much as you can, and finally integrate cybersecurity on small pieces. So at the end of the day, microservices and modular application is having the same application, but breaking into pieces that leave opportunity for the IT organization to push it faster, easier, and in an industrialized and automated way. You can see on the bottom part of the slide that the market trends are the cloud offer, so the main cloud editor on the market follows the DevOps principles, and you can see, for instance, if we can take AWS, for instance, they propose DevOps with a CI/CD pipeline, infrastructure as code. So all of the cloud providers now on the market are following and aligned on the DevOps principles. So meaning that they are full APIs, to ease automation and industrialization. They have services enabling modern architecture for application. They do propose transversal services for the run of your platform from monitoring standpoint, security, cost monitoring, etc. So it's opened the door for FinOps, for instance. And finally, there are easy integration with best of breeds DevOps tooling. So from the infrastructure as code, SCCM, build engine, etc. Now, why a showcase journey is relevant for any IT organization. So I will go in detail so how to scope it just after, but now why it's relevant. You will create a seamless team involving business, technical, cybersecurity profile. You will focus the team on long-term product, but with short-term milestones to achieve, and thus you will limit the related efforts to be done, and you will take credit for the showcase, and you will promote the showcase results and the people involved in it in order to create your new DevOps hero or champion. And finally, and this one is very important, you will find more easily the related budget for developing it. So now, in order to scope your showcase, how to select the right project to be launched. So yeah, there are several steps. The first one is rich projects. So you need to consider that on your application landscape, there are the project complexity and the needs of instability to be considered. I will give you an example. If you are working in the banking sector, everyone knows mainframe. Mainframe does not need to change every day. So it does not need to be unstable. So you need to have it the more CD as possible, so it's not a good candidate for DevOps. Regarding the project complexity here, it's to consider that, is it something difficult to develop? Is it highly linked to any other application, or I'm working on a very standard technology with a standalone application? So here the goal is to take the more unstable application, like a mobile application, for instance, and the less complex one in order to ensure you have the best ROI in there. Then which application to be considered there? So there is a technical compatibility to be considered in order to have the best application compatible to go on the DevOps path, to provide the best compatibility on it. Now, I already talked about it. It's how to prioritize. So here it's to have the best ratio between the benefits and the investment. And finally, there is a target operating model to be discussed in order to decide what do you want to do on development and production between internal and external. There are several assignments and topics to be launched in priority. So showcasing several applications, the one relevant to the business, creating a COE for CI/CD infrastructure as code could be a good opportunity for you because it's something that will be relevant in the incoming future. The more often you will use your CI/CD pipeline, the more often you will use the infrastructure as code. And finally, to transform the application technically incompatible into compatible ones to grow your ecosystem. Quickly on this one, because I disclaimed several topics, we can differ two main applications, so the one that are DevOpsizable and the one that are not. So the one that are DevOpsizable are the evolutive one, the one that have a strong front end, so a lot of interface manual with customer, either internal or end user. The one that have low flows, meaning standalone. The one technically compatible, and the one that are visible to the management and to the business. And on the contrary, the one that are not DevOpsizable, it's totally the mirror here. So the legacy one, a lot of backend, a lot of multi-flows, a lot of technical incompatibility, and that are not known for the business and the top management. Now, how to create your DevOps A-team for this showcase. So the goal here is not leaving the way people are doing DevOps right now. The goal here is to bring the tech guy working with the dev and the ops. And when I say tech guys, it's the people working on the platform, on the underlying platform, working on infrastructure as code, working on the CI/CD pipeline in order to start and induce the change within the team. And very important part, this showcase agile team must be independent in order to avoid to be influenced by the management or any legacy organization. Then you can complete this team with SMEs, experts that came from outside the company, either from outsourcing or recruitment. Then you onboard your team on the showcase that you would like to launch and promote on one or several facets of DevOps, meaning that you can take an application and say, okay, one is monolithic, I want to transform it first, the monolithic application toward microservices, and I want to use only a part of the CI/CD pipeline in order not to have everything complex at the beginning. No infrastructure as code, for instance, and after 3 months, you increase the complexity. Then you coordinate the other project DevOps if you have launched several ones at the same time with other teams, and you might need to reshuffle the team at some point from HR career point of view or from skills point of view. Finally, the last part is to increase the audit, the cybersecurity, the IT standards, and the viability of the environments, and then you repeat again. So in a nutshell, your showcase could be like, if you are working in banking, for instance, a B2C application for customer on which that you'd like to promote this mobile application for your business with a bunch of features that require several interface with the end user. Then you want to develop it or replatform it, for instance, with microservices using a CI/CD pipeline and having infrastructure as code in order to reach, I don't know, one release a day to push new features or to push new version every day. Here, the showcase, you can say to your management, I'd like to have 3 to 4 months showcase on which I will have this application totally replatformed from monolithic to microservices, and having the KPIs, the following KPIs that you can define with them. And then after the 3-4 months, you can share the results, having the most tasks completed. And if you need an extra times, you can ask to develop something extra to have any other features promoted there. So after the showcase, what's next? So as you know, because it's a very ongoing transformation, DevOps, it's an iterative approach by making DevOps a subject of adoption and skill development. So this one, everyone knows it. Then the second one, it's a bit tricky because you must dedicate teams, architecture, and environments for the showcase. This one, low to no company are doing it. I think it's a mistake because by doing it, you are able to get benefit for working like as a startup by creating a dedicated environment for that. Then you must facilitate the team adoption as they will the processes and tools they have to identify, implement, and test. And by considering the IT agile journey transformation to be tailored in the beginning, meaning that most of the company here in Singapore market have launched years ago this DevOps transformation, their cloud transformation. However, when I'm talking with my customer here, I can see that they are lacking some industrialization within the CI/CD pipeline. They are lacking some standardization on their CI/CD tooling, for instance. And finally, there are some lead time to create a CI/CD pipeline to support a new application team to be developed. So here you can see it's because they worked only on the dev and on the ops part and not on the tooling, so the IT at agile part. So my point here is that the IT organization, so the geek people in the organization must work as a team with the DevOps team. And finally, so applying the DevOps principle on eligible application, this one is important because a lot of the application landscape in the Singaporean customer here that I can see, a lot of it are on the cloud, certainly, but on IaaS application. So very legacy way of working as you had the application in data center or data room. So my point here is not to jeopardize everything. It's to take benefit of what you have, but start on replatforming 1 application, 2 applications, 3 applications, and you already did it, maybe think if it was the good way of doing it. And you can start it again, for instance, with a compatible standalone application that will fit for a showcase. And on some environments, meaning on your dev environment, on your seat environment, your production. And then you will be able to spread a end-to-end DevOps culture within your company, leveraging this showcase by improving it using the showcase post-mortem and industrializing it is a sustainable approach. Again, the sustainable approach is clearly missing in the company here, one that I've seen, because there are no too low tooling from a CI/CD pipeline or infrastructure as code point of view. Then I think it's the last part of it. You can extend this showcase to all target environment and defining a standard deployment pattern and principles. here I can tell you what I've seen and what I've done in the US and in Europe, is that we create a dedicated environment in order to have an end-to-end DevOps environment from business to development to operation to the IT, so the underlying platform and services. And we moved iteratively the different application monolithic to re-platform one under a new environment with a dedicated operating model that brought value to the business. I will conclude here that implement DevOps and in an agile way to quickly deliver value and share results to the business, but also to mitigate the risk. So DevOps is agile, so is implementing DevOps at scale. I have 5 minutes now with you guys in order to answer any question that you can have, and I have a bunch of appendices also if you need to go further in detail. Thank you.
Any questions from the audience?
Yep.
Hi. So my question is actually around scoping the initial, let's call it a showcase, or your initial screening of what you want to call it. Because these are monolithic systems, right?
Yeah.
Trying to decouple the dependencies is really tough. What's your suggestions in how to take the first bit?
So when you're talking about dependency, are you talking about dependency within the application or with other application? So within the application, there are several approaches for doing it. So there is the code retro or reverse engineering in order to define the 3 main layers, which is UI, UX, front-end, back-end. Then there are common features on the front-end and the back-end that you can rely on. So there are several patterns of standard monolithic application in order to match as possible what would be the microservices one. So my point here is that you can have 20 days to reverse engineering the application and then map as much as possible the current features in it to what could be a containerized application in the target. Okay? No, it's architect, it's design. It's just design. Yeah, you need to have this document in order to start creating a low-level target. Because if not, it's like creating from scratch a new application. Any other question? So, if I understood the question, is you are asking the leader of the market to work on that kind of development activities? Leader in the company. Okay. Okay, the middle management. Okay, so it's an incentive question. Okay, so regarding incentive, there are 3 ways that I was handling that topic. The first one is from the HR standpoint. So you must talk to the leader of the company in order to review the goals and the objectives of the middle management. Here you can incentive the middle management to work on the showcase or to support the showcase by putting it on their goals. Because at the end of the day, if they are not supportive, no bonus, no money, and so on. The second topic is to promote the HR career path for middle management regarding DevOps in order to be fully ensured that they are working to develop their skills also on that. And finally, the last topic is to create an incentive around, it's what I call, it's like promote the success. So you put in front some of people, the middle management, in order to take benefit of what is done for that. So it's 3 ways of answering it, really related to HR. Okay? another question?
I had a short question.
Sure.
I mean, actually two, but we are out of time, so only one. You mentioned that what you called DevOps sizable, was it right?
Yeah.
Very nice expression, by the way. You said it's mostly like front end, more or less, in what you stated. From my personal experience, I see DevOps sizable more on the back end side because I'm more from so when I see a front end, I always want to do an A/B test, right?
Yeah.
And doing A/B testing is something that takes time and is not trivially DevOps sizable. And so for me, things are much easier to put into a proper CI/CD DevOps process on the back-end side instead on the front-end side. What is your stance?
So I was talking about the showcase. So it was very showcase oriented. But you're right. You're right. I was very showcase oriented, meaning that it's easier for front-end application like a CRM, for instance, compared to say, okay, let's go for an ERP. So no, at the end of the day, yeah, you will have some backend application that bring a lot of money that will be very relevant to be on the microservices application to use your CI/CD pipeline.
So let's thank the speaker again.
Thanks a lot.
Can you hear me? Hello. Yes. Okay. Thank you, everyone. Okay. So my colleague is the books about Vanish. So we are Vanish. We are the company. Actually, it's Vanish software behind the open source project Vanish Cache, which is if you heard of anyone heard of Vanish Cache, or they use it, okay, part of it. The rest of the people, they don't heard of Vanish. Just a quick introductions. Vanish is doing HTTP reverse proxy. It's kind of web caching daemon. If you compare some of the solution in the market, it's about Nginx or HA proxy. Very similar products, but different objectives. Vanish is only focused on caching. Nginx is more like application. You can put a lot of module plugin, and HA proxy just do routings, sharing, load balancing. We can do both, but we are really focused on the caching side. So here we have the website, the event website. Also, we will exhibit in Broadcast Asia as well. If you want, you can join us in Broadcast Asia. So Vanish, no, yeah, that's why the guy at the very beginning developed Vanish, because slow website sucks, right? Back to 10 or 20 years, he's still running the Windows, and then the browser doesn't start, and it just throw it away. So this guy accelerate the website. So that's what we do. Okay. So we build the software that define the web acceleration and content delivery solutions. It's mainly right now, nowadays, we focus a lot on CDN development, OTT streaming, web API, e-commerce, online shoppings, this kind of service, like a TikTok, also some video scripts. It's also our targets. Here is our commercial partner base. It's also use the open source version at the very beginning, and then later on they move to the enterprise. They need more support, more features, but those of them actually start with open source projects first. If you look in your projects, some scaling problems, you have problem in scaling the database, the application itself. Actually, you first look into the caching, see whether you can scale up in the caching level, because caching level is easier to scale up. For us, it's just replicate the instance. You have all the service. We have different sector streamings, Hulu, Netflix, they are using our solutions. Even in manufacturing, Tesla, somehow they use our solution internally, web API, to accelerating the whole workflow. Because across the world, they have a lot of factory and fetching the footprints and design and all these things. They will use the Varnish to scale up and speed up the system. Okay. So what is Varnish? Actually, Varnish just sit between the client and the backend. The client can be your browser, can be your cell phone. Actually, the client can be another system. So in the nowadays world, we use like a Kubernetes, Docker environments, all this cloud system. You have microservice. The client can be other microservice as well to talk to another backend, another microservice. In between, Varnish can cache all these requests, HTTP requests, and then respond. We can do some logics in the cache to speed up or aggregate the response. So that's why we have the web API acceleration or the edge computing. Some figures just to share. Just 2 months ago, we reached about 1.4 terabit per second in a single server. So if you are doing OTT streaming or video broadcasting, we are very good in that area, and actually we save a lot of power comparing the per gigabit per second delivery. So what we do is more than 1 gigabit per second in 1 watt. Okay, if you are talking about ecosystem saving, carbon quota footprints, which is very good in the company future. Okay, so some very generic or technical stuff about Varnish or HTTP, how it works. So if you don't have the caching or whatever in between, the client just come in and get the content from the origin and going back. In between, you can have some HTTP daemon, or you do a memory caching, disk caching for your application itself. Redis, Memcache, all these components, you can use it in your application to speed up a little bit. But still, as long as more user coming in from the internet or from other area, the system will fail up. Okay, because it's really difficult to handle or scale up in this level. So what can we do is Varnish cache. Okay, Varnish cache, we put it inside, in between the client and your origin or your applications. Then the Varnish cache actually to do 2 things. One thing is queuing up all your requests. If we don't find the cache in the memory or on the disk, then we only send requests back to your backend to fetch the content. So from this point of view, let's say you have 5 requests right now. At the end, you only receive 1 from the origin and then respond back to the client. So the latency here is very minimum. We just pause it until we got the response, the first byte response from the origin, and then we're going back to the client. So no matter it's a web API or OTT streamings, the latency is very important for live streaming. So in between, we add up probably 10 milliseconds maximum. So we get the response back to the client. And also you can scale up. You just add more instance. Then you have horizontally scale up your application without touching the origin, right? The origin will be more or less the same. Okay, so once we cache the content, actually we don't even go back to the origin. Okay, the origin is completely isolated from the client. Actually, we add additional tier of the security from the application. So you are protected, separately from the client side directly. So the client doesn't reach the backend. Okay, the core component is more on the technical side, how Varnish work. Varnish actually divide the whole system into several components. One is the core engine, the Varnish Cache API, there's the core engine, and also the flag pools. So we have multiple flag pools architecture. On the top, we use called VCL, the Varnish cache language, to configure how the system behave. And also we have the readmon, the module, the plugin, to add on some other feature. All these features you can create by your own, open source, and also some enterprise readmon that you just plug in, and then you have more feature on manipulating the requests. Behind the bottom two part is about the storage engine. First, we use the JE malloc to use the memory, how to allocate the memory and the linked list to cache the content. Or in the enterprise version, we have the MSC, the mass storage engine. We can combine the memory and the disk to deliver the content more efficiently and use your capacity more efficiently. And then the next on the right-hand side is the VSM, the shared memory module, which is more powerful to get the logging or the system status from the core without affecting the incoming requests. Okay, one of the things we can talk about is about the logics in the core. Is about the final state machine. The final state machine allows Varnish to manipulate the request at different states. So once you get the request, actually you can manipulate the request how we respond, and also manipulate the response from the backend. So all these states we can do very specific modification or decision making. It allows us to deliver more efficient and more details of these manipulations. Okay, here is the high level the state machine, how it looks like. So when we coming in from start, the request coming in, then we will do a hashing to look into the cache. If we find the cache, we will respond to deliver. We will go back to the deliver. If we find hit, we will hit. If we don't find the cache content, we go to the miss and then we fetch it from the backend. So each state, each square box actually can put logics there and to see how you want to manipulate your request. So most of the time we manipulate from the backend fresh. So you have multiple backend, redundancy, all these things, or load balancing. The logic is done at this level. If you want to manipulate the request, usually what we did it is modifying the response in the VCL delivery. Okay. So that is the VCL and readmon. Yeah, as I said, VCL allows you to manipulate the incoming request and control how and where to cache the response. Of course, you can modify the cache objects lifetime, how to respond or delete the objects. And internally, we have different objects to manipulating the request. Let's say response, backend request, backend response, and also the generic objects. All these things you can access it from different API. You can extract the status, so you can use Prometheus or other module to display all this status graphically. Okay. So some things more sample about the backend flash. So we use this one to do round robin for the backend, redundancy, request routing or sharding to do more consistent hashing for the backend requests. All these backend can do health check to make sure your backend is healthless and send the request to make sure your service is up and online all the time. Okay, backend response. Usually, if the backend respond a positive result, let's say 200 error, 200 code, or you have other code like a 503 or 404, this kind of error code, you can specific how to handle it. When you have a response, we can set up the TTL, that's the cache object in your cache, how you want to save it in the cache, how long you want to save. In that level, Varnish use three different values. One is the TTL, the original lifetime, and other one is the grace period, and the last one is keep. So when we use the grace and keep period, actually there's a magic that allow the cache to keep a little bit even longer out of the TTL time. Then once if you have problem of your backend, actually you have an option to get the content from your cache even that is expired. So there's a lot of other logics and metrics you can play around with the vScale to retrieve the cache. So the VSM, which is the shared memory, that's export all the status, the memory fat, and all this thing to this area. So we can do it for analytics, logging, and also we provide a very powerful query. We call it VSQ to query the memory, the log from the memory. By default, we don't keep the logs. Okay, we don't like Apache or Nginx. We don't send to syslog or whatever. We do the logging from external tools. You have to integrate with other systems to get the logs, because the logs in, let's say, in CDN, in OTT streaming is massive. So usually you export it to Elasticsearch, Prometheus, this kind of database to keep it for longer times. So because the system doesn't keep the logs, the I/O on that part is very minimum. So that's why we are so efficient in handling the requests. We focus on that part. We don't spend or waste the I/O to keep the logs. Okay, here's the log. If you familiar with the Varnish, here is the Varnish log, how you extract the details. So we extract all the information from the VSM. There's only one request. So the request, you can see how it's coming in and out and why. So if you're doing troubleshooting, if you know the HTTP spec, you have all the details. Okay, and here's the log and statistics. Okay, VCS. We do our own internal counter as well. So not only the logs, but also the counters. Okay, and then the caching API and the store. So I just skip those store things, but I want to focus a little bit on the massive storage engine, which is the way how we store the cache content. Normally, what we write as files to the cache, we just have the the file tables to keep the file headers and the file name and then the content. In Varnish, how you keep the cache, actually we split into two parts. One part is the metadata, and another part is the exact cache body. Doing so, we have the flexibility to just delete the cache from the metadata, not exactly from the storage. It's meaning we reduce the I/O a lot until we search the whole block of cache has been deleted, and then we will use the database, the metadata, to clean up the space. So we save a lot of I/O and more efficient to use the storage and less fermentation. So by using this one, actually some system can run for more than 3 or 4 years without reboot. It's still running. The disk doesn't crash. The fermentation is very low. Okay, in validations, I have to skip it. So let's go to straight about web API stuff. It is work on the marketing place. So the web API stuff, mostly you use the RESTful API, which is HTTP related. Let's say AJAX call, HTTP request, post, or with the query strings, all this thing. The engine itself doesn't care about what kind of query or post parameters. we can cache everything as a index. So when you query or using the get or post, this kind of resources method, you can cache it by the Varnish cache. And it can be shared with multiple requests without talking about, how to control the TTLF or all these things. The magic is done by the resale. Okay. Of course, you can follow the cache control headers or other headers, but most of the time, if you're doing API call, we will override and very specific on how you want to handle it. And for these web API, some of the users use the SI insert, ESI. That's like a template. So the server side just send a template with the ESI code, like this one, ESI include, and then you will include another files. So the system will cache both, but then this dynamic content or with some logics, programming logics, you can dynamically or on the fly to request another, to trigger another request to generate a file. It's just more like you have the JavaScript on your browser, but it is not on the client side, it's on the server side. Okay. Also, you can create more other HTTP requests at the same time, not only the original request. So we rely on another readmon, we call HTTP readmon. During each call, we can create additional HTTP requests, just like this one. So when coming in, I create another request, I copy the headers, and then I check the authentication. Okay, another one is edge stage. So it's kind of a template, just like the Go template. So, but it is on the website. So you put some logics and also combine with the JSON objects structure. And then we just put it here to generate content on the fly. It's more like you put the web server on the edge, but it's not exactly the same. We aggregate the content from different backend. Okay, this one will be, for to fetch the JSON objects from another application server, and then massage and then generate the layout. Yes. As long as you can. Some of the files is like 1,000 lines or 2,000 lines. Here, it doesn't matter. We don't limit you. So just say for loop or inside loop, we don't limit how many loops you have. Of course, we can have some memory control because it uses memory on your cache. So it's mainly on the startup, how much memory on this worker space. So if you have more loops inside this block of logics, probably you need more memory on the worker space. Otherwise, we don't care. Logically, there's no limit. The limit is by the memory. Okay, like the Go language template, less computation, we just template and then aggregate everything together. We also support gzip, so that means if you fetch some content like a JSON object, you can zip it and unzip it on the fly. Okay. More integration about like a Redis, so this completely open source. If you want to, keep track all these sections along with the whole cluster, let's say the cluster have 10 to 20 POPs instance, you can use the Redis to share the information across all the logs. So just like this one, the Redis client dashboard is an additional readmon. We call it additional module that talk to the underlying Redis bus, the Redis daemon. And then, okay, I want to get some session data and then update the cart, the shopping cart here on the fly. Okay, it's more like a programming on the edge, and actually it does. And yeah, it's more efficient than you write Nginx or PHP code here. Okay. Some configuration less about networking, control the speed and rate limiting. Here is about rate limiting. So you can limiting, filtering, or checking what kind of method you want to accept. Some kind of security things you can do on the edge in Varnish. Okay, checking the rules from the incoming request, or actually the method the same, but this one is more like a HTTP standard, the specification. If your request is coming through with English, Chinese, or Korean, then you can block or accept or create different version of cache. Okay, this one will affecting how you cache the objects. And more Widmon that we can put in your system, Xbody, another Widmon to manipulate the response. So the response probably can be a XML or other HTML files. You can replace it or we can update it. And MMDB like geo-blocking database, device database. You can base on that device ID or location to do some additional decision. HTTP module that we show it additional requests to send additional API call. JSON object, you can pass the JSON on the fly without doing a regular expression or something kind of like that. JWT, JSON Web Token, is a built-in module that you can verify the authentication, the token itself, to allow and disallow the request. UDOs or go to the director, how you manipulate or control the backend traffic accosting multiple backend. Synthetics backend, more like generate a new page or new response other than the backend. Okay, I think that's it from my end. So thank you very much. Any questions before we wrap up? Thank you, guys.
So there was the first question. So apart from Redis, any other data sources that we can...
There's only an example. There's a lot of other modules that you can integrate. Redis, Memcache, and mostly the Next. And it's open source because there's a lot of things happening all the time. Do you have any existing projects you are trying to connect? Then we can talk about it. Sure. Yeah. Yes, Graph SQL actually by default is already there. It's just an exception how and what kind of query you want to cache. So this is nothing, it's no magic because Graph SQL is more to us is just like a HTTP request, and there's no magic or no specific things we need to handle. Just one thing we find some difficulties it's not difficulties or issue is about what kind of images you want to cache at the same time and how long you want to cache. So that is only the things. Otherwise, they just go straightforward. We have some issue with some integration, but not too difficult to solve it. Yes, exactly. That's all you need to do. Yeah. Yes.
Actually, sorry, I just want to comment on that as well, because Grafana is actually post. Don't post normally.
We can support it. So that's why there's something you need to change, or you can adopt it, or you change the post to get, or we can allow you to do the post. So if you do the post, that means you have the body from the request, because usually the body from the request will be ignored by default. Then you need to open up the parameters to allow how much memory you want to spare to post the object. So that is something you need to consider. There's two versions. So the open source version, we still run on Hitch. If you know, the Hitch project actually is still under the Varnish software as well. It's a separate module. They do only the HTTPS termination, TLS termination. But the enterprise version is we built in the TLS termination. We don't need to do anything. We just bring it up. It will work. No more, no problem. Yep. I think it's already there. I haven't tested the new version that our new release on open source, the version 7 is already support that one.
I don't mean the actual implementation, the actual standard protocol.
Yes, yes, the version 7 that they claims, you know, the open source version, they claim they already test on that version, but I haven't tested myself. And the enterprise version is still based on the previous version, 6 or something. So it's not the latest one. The ESI syntax is not the, we not compile the whole set of ESI. We compile most of them. Because the rest of this function, we can do it by other widmon. It's more efficient than using the ESI function. Okay, cool. Any other questions?
So I have a question. So
Yeah.
because I worked in a CDN company myself for many years.
Okay.
One part is the software, the other part is where the actual servers.
Yes.
Do you work on those tools or do you provide only the service?
We rely on our partner to provide the platform, but we work with Intel very closely. Actually, the coming slide, extra slides about Intel stuff. We do a lot of Luma integration to speed up to use the CPU more efficiently, especially in the cloud environment. Because in the cloud environment, they don't really aware the Luma. Because when you have the I/O and the NIC card all together, you have 10 gig. We are talking about 1.4 terabit per second in one server. So it's not. Is in the memory, and the memory and the I/O.
Yes, so I said before I was in a CDN, Japanese only, but quite big in Japan. And for us, the big problem was not on the net, but on the
system.
And I/O.
Exactly,
So
exactly.
That's a very good point. Thank you.
Yes. Okay, thank you very much, guys.
Further question? Let's thank the speaker again.
Thank you.
Handling failures for first. First principle.
No. Really? Oh my God.
Okay. I was intrigued because in the description of Dominic was a point about formal modeling.
No, that's unfair.
So that's not true.
Yeah, that is true.
Actually, because I also write, not my spare time, but from my old time, I write the formal specification verification language myself. So I'm very interested to how you did this. I see it from Temporal and talking about first principles and how to deal with failures. So please welcome the speaker.
Thank you.
Thank you. So Werner Vogel, the CTO of AWS, famously said, everything fails all the time. So for Werner Vogel, the question was not how to avoid failure, but the question was how to handle failure. So I am Dominic Torno. I'm a principal engineer at Temporal, and I focus on systems modeling, specifically formal modeling and conceptual modeling. I work at Temporal, and Temporal is an open source platform for durable executions. And durable execution is to a distributed system what a transaction is to a database. An abstraction that enables you to build an application as if failure doesn't even exist. Now, to provide this guarantee, Temporal built a lot of expertise in failure handling. And today I'm super happy to be here at FOSSASIA Summit to talk about handling failures from first principle. So a first principle approach breaks a domain down in its basic principles and then builds an understanding from these basic principles instead of relying on unspoken assumptions or on conventional wisdom. So in this presentation, we will think about failure and failure tolerance holistically. A failure is an event in a system. Failure refers to an unwanted but nevertheless possible event. Failure tolerance is a guarantee of a system. Failure tolerance refers to the guarantee that the system behaves in a well-defined manner, even in the presence of failure. Now, in other words, if a system is failure tolerant, then the system trivially guarantees total correctness
in the absence of failure. But it also guarantees at least partial correctness in the presence of failure. And if the system is actually able to guarantee total correctness, even in the presence of failure, we speak of failure transparency. Now, failure transparency is obviously the most desirable property, but it's not always possible. So think, for example, of the CAP conjecture. I think it's a database-heavy crowd. Think of the CAP conjecture. The CAP conjecture states that for a replicated data store, you have to choose between consistency and availability in the event of a network partition. So in the absence of a network partition, the network partition is a failure, the unwanted but nevertheless possible event, the system is able to guarantee total correctness. It is able to guarantee both consistency and availability. But in the presence of a network partition, the system is able to only guarantee partial correctness. We have to choose between consistency or availability. Yeah, but the good news is at least you get to choose. As a designer of your system, you get to choose what failure tolerance means to you. You get to choose the guarantee you want and is important for you. You get to choose if you prefer consistency or availability. So failure tolerance is a design decision. Now, in order to talk about failure holistically and what kinds of failures we expect and what kinds of failures we need to tolerate and what guarantees we need to make in the presence of a failure, we need to first look at the underlying system model where the failure actually plays out. So system model is a set of assumptions about a system, yeah, and algorithms and protocols that are correct under one system model may not be correct under another system model. Yeah. Any deviation may render any algorithm or protocol incorrect. So you can think of a system model a bit as like a board game. Yeah, and the game sets the stage and the game sets the rules. And as a player, you have to devise a strategy to achieve the game objective within the constraints that the game sets for you. And even a slight change to the rules may render a player's strategy completely ineffective. That happens a lot with extension packs. Now, for this presentation, we will think in terms of a very popular system model in a cloud environment, in a microservice environment, and that is in terms of service orchestration. So a system is a collection of processes. And one process is a sequence of steps. And one step is a networked call to an upstream service. Here, a single service call has transaction-like semantics. It's atomic. Right? It either happens completely or it doesn't happen at all. However, the sequential composition of service calls does not have transaction-like semantics. The sequential composition is not atomic out of the box. But we also want the sequential composition to be atomic. We want total application, not partial application. So in the event of a failure, we need to ensure that the process executes in one of two ways. Either observably equivalent to exactly once, total application, or observably equivalent to not at all, no application. So the classic example is certainly travel booking. And many of us traveled to be here. So our credit cards were charged when we booked hotels and flights. Each step is in itself atomic. However, we also require the composition of the steps to be atomic. We expect exactly one charge, one room reservation, and one ticket. So to keep things simple for the rest of the presentation, whenever we need a concrete example, let's talk about charging the credit card, the charge credit card service call. So, what failures do we need to tolerate? Yeah? What could go wrong? Well, it's a microservice environment, it's a networked call. So the request may be lost in the network. the service may crash before the computation takes effect, before the credit card charges. The service may crash after the computation takes effect, so after we charge the credit card. Or the response may be lost in the network. And in the absence of a response, we actually don't know if the intended effect happened or if it didn't happen. We cannot distinguish whether the failure occurred before the computation took effect or whether the failure occurred after the computation took effect. So we may end up in an inconsistent state. And additionally, the computation may simply return a failure error, raise an exception, like an insufficient funds exception. Yeah. So there is a response, and the response itself indicates a failure. Okay, now what are we going to do? Yeah. How are we going to handle that failure? Failure handling always consists of two components: failure detection and failure mitigation. The first component of failure handling is failure detection. So it refers to the mechanism that detects if a failure has occurred. Now, generally, I struggle a bit with the notion of failure detectors in distributed systems. Most authors focus on detecting component failures or emission failures, crashes. But I like to cast a bit of a wider net. So when I think about failure detection and failure detectors, I generally think about witnesses, a predicate that confirms the presence or the occurrence of a failure. Very common example for witnesses are exceptions, right? Where the system itself tells me something went wrong, but also timeouts. We're waiting for something and it doesn't happen. That is also a pretty good indication that a failure has occurred. It is not certain, but it's a good indication. Now, the second component of failure handling, that is failure mitigation. It refers to the mechanism that actually addresses the suspected failure or resolves the suspected failure. And broadly speaking, especially for our scenario, there are two failure management techniques. One is forward recovery and one is backward recovery. So remember, the process is a sequence of steps and any partial execution is undesirable. Therefore, in the event of a failure, we need to ensure that the process executes in one of two ways. So observably equivalent to successfully, total application, that is what forward recovery is responsible for, or observably equivalent to no application, that is what backward recovery is for. So let's look at forward recovery first. In the case of a failure, we just move the process forward. So more formally, we transition the system from an intermediary state to the final state. And as a rule of thumb, we need to repair the underlying failure because we try to push past it. We need to resolve that failure. Forward failure recovery is a very common platform level failure mitigation strategy. We simply retry, right? Something goes wrong, let's do this again. Something goes wrong, let's do this again. Sorry. Next, let's look at backward recovery. In case of a failure, we roll the process backward, or more formally, transition the system from the intermediary state back to its initial state. And as a rule of thumb, we don't have to repair the underlying failure. We're not trying to push past it. So backward recovery is a very common application level failure mitigation strategy. We compensate, we undo what we already did. We reverse the charge on the credit card. In order to choose the ideal failure handling strategy, what are we going to do when a failure occurs? We also need to take the class of the failure into account. We need failure classification. Now, obviously, there are hundreds of different ways of classifying failure. But here I want to focus on two orthogonal dimensions. That's the spatial dimension and the temporal dimension. On the spatial dimension, we can classify failure as an application level failure or a platform level failure. So in order to do so, we need to think about a system in layers. Components at a higher layer usually make calls, down calls to components at a lower layer, and generally they're expecting a response. And the end-to-end argument states that in a layered system, failure handling should be implemented in the lowest layer possible, looking from upside down, that is able to correctly and completely handle failure detection, failure mitigation. So now a failure can be classified as either an application level failure or a platform level failure, depending on the lowest layer that is able to detect and mitigate the failure. So for instance, an insufficient funds exception indicates a application level failure. The application level is the lowest layer capable of correctly and completely resolving that failure. That failure is completely meaningless on an application level. But a could not connect exception, that failure indicates a platform level failure. Although the application itself could potentially mitigate that failure, the lowest layer that is capable of correctly and completely mitigating that failure is a platform layer, which can just simply be retry. We retry in the network. On the second dimension, on the temporal dimension, we can classify failure as transient, intermittent, and permanent. A failure is transient when we can assume that the probability of a second failure after the first failure is not elevated. So formally, a transient failure is defined by two characteristics. So first, the probability of a failure F2 occurring after a failure F1 already occurred is the same probability of F2 occurring just by its own. And transient failures are auto-repairing. They need to repair themselves. Otherwise, they're by definition not transient. So we do not need any intervention. In our example, if the cause of the could not connect exception is, for example, a router restart, then that is a transient failure. The failure repairs quickly. Once the router restarts, the connection can be made. The second class is an intermittent failure, where we can reasonably assume that the probability of a second failure is elevated. So formally, an intermittent failure is defined also by two characteristics. And firstly, the probability of a failure of F2 occurring after another failure F1 already occurred is higher than the probability that F2 occurs on its own. And intermittent failures are also by definition auto-repairing and resolves themselves without any intervention. In our example, if the cause of the failure is an outdated routing table, then the could not connect exception may be an intermittent failure. The type of failure auto-repairs, but with some delay. But as soon as the router updates its routing table, the connection can actually be made. And if a failure is permanent, we can reasonably assume that a second failure is certain. So formally, permanent failure is defined by two characteristics, where the probability of a failure F2 occurring after failure F1 occurred is 100%. And secondly, also by definition, permanent failures require manual intervention. They require manual repair. In our example, if the case of the failure is an expired certificate, then the could not connect exception is a permanent failure. Yeah, that failure doesn't auto repair. Somebody has to come and install a new certificate, otherwise it doesn't go away. Now, with all of this together, for this particular system model and for that particular failure model, what could an ideal failure handling strategy look like? Right? And also, what is ideal? What is ideal for me may not be ideal for you. It's a design decision. Right? But let's look at one that I think is a reasonable failure handling strategy. So in the event of a failure, first, let's assume it's a transient platform level failure. So we retry immediately. Right? Let's not wait. Immediately retry. If the retry succeeds, we successfully mitigated the failure. Done. If the immediate retry does not succeed, we just need to upgrade our understanding of the failure. Yeah, now let's just assume that the failure is an intermittent, yet it's still platform level. It's auto repairing. So we just retry a bounded number of times, and typically we do that with exponential backoff. Yeah, again, if one of the retries succeeds, done. Successfully mitigate the failure. If none of the retries succeeds, we once again upgrade our understanding of the failure. Yeah? We can still assume that the failure is a platform level failure, but now we need to assume that it is permanent. So the process basically suspends and is awaiting the repair of the underlying failure. We need manual intervention. If that does the trick, once again, we mitigated the failure. If nobody repairs the failure in time and manual intervention doesn't happen, we need to upgrade our understanding of the failure once again. And we now assume it's an application level failure and we are ready to compensate. We are rolling back whatever already happened. And if the compensation is successful, we successfully mitigated the failure. If the compensation is not successful, we're in the worst place to be, and then we basically have to escalate to a human operator. If we charge the credit card, but we cannot roll back the charge on the credit card, we cannot undo the charge, somebody has to sit down, write a check, and mail the check. Or however we're going to resolve it, but we have to resolve it outside of the system on a level of a human operator. Now, as a conclusion, failure and failure handling and guaranteeing failure tolerance and working on failure transparency can be super intimidating topic. But it helps me a lot to take a principled approach, to think about failure holistically and then implement the failure handling strategy with confidence. Now, if you want to get a head start, then check out Temporal.io. Temporal takes a principled approach to failure handling and implements the concepts that we have explored today on a platform level, guiding you towards an ideal failure handling strategy for your distributed systems. And with that, thank you very much for joining. Super happy to answer any questions you may have in person, or feel free to reach out to me also online. For example, on Twitter at Dominic Torno. And then, yeah, thanks again. Thanks again for being here.
We have ample time for questions. Please go ahead.
Can you describe what the open source aspect of this
So Temporal is an open source project, and it is a platform for durable executions. Now, I like to contrast also durable executions to volatile executions. Volatile executions are just simple function executions. And think of any simple function. It only provides you weak execution guarantees. The function may crash or the function may time out. Right? And that may lead to partial application. Now, Temporal gives you durable executions. And durable executions are function executions with strong execution guarantees. Yeah. The function execution cannot fail, and the function execution cannot time out. And yeah, it's an open source project, and check it out at temporal.io. Please.
How do you deal with the halting problem in some of these systems? Because you described a process with several steps, but that means you have to have a system that's detecting failure.
Correct.
And how does that system know the difference between a failure and something that is just taking a long time, a step that is taking a long time to process?
Yeah, it cannot.
Everything in timeout?
Yeah, yes, correct. So you are correct. It cannot. It cannot know. It is an impossibility result in distributed systems that it's either complete or perfect. And what systems I mean, in this case, the approach that we take is we suspect a failure, even if the upstream component is just slow. And therefore, any stragglers, any delay responses will be omitted, will be discarded. But you are entirely correct. You have to deal with the fact that the computation of that request actually happened. So your system must be able to either roll forward or roll backward, whether the computation took effect or didn't take effect, which is actually it's not easy to do, right? It's basically impossible to do on a platform level unless you know the semantics of the operations like a database does, right? I know what a write does, so I can undo a write generically. But for like any service call, I don't know what is the undo operation of a credit card charge. We don't know that on a platform level, right? So it requires the cooperation of the application programmer, and that's actually quite a feat. Yeah. It's quite a challenge.
The concept for durable execution is actually quite interesting, but I suppose what makes me wonder is at what level do you actually want to be able to handle failure? Is it when it crosses the network boundary, when it's actually executing the code? How do you understand where to handle that?
Yeah. So there is so on the system model, right, that Temporal takes into account, there are certain failures that we can handle on a platform level, and these are transient failures and intermittent failures, right? So failures that can be resolved by a retry and by forward recovery. We can handle that completely on a platform level and do not require the cooperation of the developer, although since we're retrying, we do require idempotence on the upward service calls. But as soon as we talk about application level failures, like the insufficient funds exception, right, there is no way that we can push through that on a platform level. So at that moment, we escalate to the application level, and these are the exceptions that you have to take into account in your code. So the compensation can still be found in the code. Often called sagas, right? So the compensation can still be found in the code. But on a platform level, we can take care of intermittent and transient failures, transient and intermittent failures. We can also we can help you deal with permanent failures by not abandoning the function execution. Usually, a function execution, when a function execution like encounters an exception, it just poof goes away, right? And then, if in doubt, you don't even know that it happened, and it just went away. So the temporal durable executions, they do not go away. They suspend at the failure point. It just sits there and wait, right? So I can go in if I'm still within the timeout of the overall durable execution. Some of our durable executions run hours, days, weeks, months. We have actual users that use them in the course of years. So they service 30-year long loans, one durable execution. That suspends on the failure point, and then you come in, you fix it, and then it just resumes as if the failure never happened. It's transparent to your code. It's actually pretty slick.
If not much time left, so I would suggest to take further discussion offline.
I was just about to.
Let's thank the speaker again.
Thank you. Yeah, please. Thank you again. Thank you very much for being here. And then please come find me. We can talk downstairs in the hangout area. And I also have temporal stickers if anybody wants a sticker. Thank you.
Okay, that sounded nice. All right, let me try to do this. Okay. Okay. Oh, we are already in. Hello everyone, good afternoon. Thank you for joining for FOSS all the way. That's, if anybody wants a tip to get a talk in for any summit, just try and put the summit name in the title. That typically works for me. So my name is Yogi. A few things that you will realize from this slide is I'm fond of emojis. I like to travel. I've been to all those countries. I'm always exploring ways to get to new countries. And just below that, you'll find all my hobbies. I'm Indian, so like cricket comes naturally to me. Yeah, I've been living in Singapore for almost 2 decades now. And currently, I'm a solutions engineer at YugaByteDB. And just in case you didn't realize, it's not YDB. So it's probably like YDB and YugaByteDB. It's a little confusing sometimes, but yeah, we are YugaByteDB. I am working with like our YugaByteDB partners and customers across Asia. So, you know, India, Singapore, Philippines, Indonesia, so on and so forth. And I have been involved in a lot of cloud native communities and also app development, cloud native platforms in past and now also. The QR code is my contact if you want it, and those are all the places that I have worked in past 2 decades, I suppose. Why are you here? Like, just in case if you're not sure, this is the topic for talking about Kubernetes, distributed databases, and Kafka, and everything in between. I'm going to have some slideware, probably about 150-ish or slides. No. It's, I promise it's going to be only 40. But I'm going to do some live demo. Hopefully it works. Did not give my sacrifice this morning, so fingers crossed. So a lot of things have happened in last sort of decade, in the sense that we went through a massive shift in paradigm. People are moving towards cloud native applications, cloud native platforms. We are talking about Kubernetes, containerization, moving to public cloud, moving back from public cloud, moving to microservices, moving back from microservices. It's all happening, right? I mean, it seems very cyclical. And you know, if you were there for the earlier 2 talks, I think the topic is quite well placed because it is what I'm going to talk to you about. It very well fits into that same story around DevOps and the consistency. So, when we talk about anything in technology today, the easiest way to start is if we start with an app, right, which is solving a sort of user problem. And typically, when we say an app, it may mean different things for different people. If you ask somebody who's born in like last 2 decades or decade and a half, for them an app is on their iPhone or Android device, right? Pretty much that's what it is. Maybe iPad, right? Some people, like I'm a kid from 90s, so for 80s or 90s, right? So for me, it's a piece of software, right, or a program. So in essence, I would say an app is a piece of code, right, that is executable. So typically, when you take an app, you need to run it. Now, to run it, what do? You take a compute, right? The compute can come from a virtual machine or a pod. And your application doesn't live alone. It actually has some supporting things. Oh, by the way, one more thing that you might notice about me, I like minions. It's competition between me and my daughters. You saw their pictures earlier. So typically, they have their own supporting services that they require. It could be for some sort of networking capability or some sort of organization, compliance, enforcement kind of practices, right? It happens. It is there. And typically, in enterprises, an application is never run as a single thing, right? You normally run multiple instances of it. So far, so good. Now, in the modern applications, in the cloud native world, what we have is a container orchestrator or an infrastructure API provider like Kubernetes, which basically takes care of taking your code, your containerized code, your application, and running it on the actual hardware. It could be on the cloud, it could be running on premises. That's right. But again, I mentioned about all sorts of sidecars and compliance capabilities and all those things. But apart from that, you typically have certain supporting services. You may have messaging systems, you may have database systems, and everything in between, right? Authentication, identity provider, all sorts of things. Now, as we move towards a more and more cloud native architecture, we try to move as much as possible to the cloud native platform. Kubernetes, right? When I say cloud native platform, it's, for me, it's same as Kubernetes. Now, this is like interesting because you obviously, we talk about the cloud native platform and Kubernetes and all, but typically you have multiple sites and multiple regions, multiple data centers, or it could be cloud regions and things like those, right? So everything that we spoke about so far in your mind, if you're going through, oh, okay, I can actually run this command to deploy this, and I can keep a copy of this through this command and blah, blah, blah. Well, all that is doubled now, right? Or tripled in some cases. So something that I always get asked is like, what are you talking, like running database on Kubernetes? Are you insane or something? Yeah, I am talking about running database on Kubernetes. Why should you actually run database on Kubernetes, right? Now, Kubernetes has actually facilitated better resource utilization. What it does for us well is that it allows you to use your compute, your infrastructure in a more efficient manner. So rather than dedicating your compute for certain applications or certain pieces of code, you can actually treat it more like a kettle. Anybody can tell me what's the difference between a kettle and a pet? Not you. So typically for a pet, you have a name, right? It's Goofy or something, right? But for a kettle, like as a kid, when I was living in India, I had like 5 cows. None of them were my pets. Like I was like, okay, one of the cows. Like go milk one of the cows, right? I don't know which one, but just go milk it. So that's a difference. You do not actually have a direct attachment or like sort of naming or strict dependency on a kettle mindset. So that's what Kubernetes is actually providing for us. It provides you with the capability to run a variety of applications in a very standardized manner, and not just running the application, but also connecting it to the underlying infrastructure. It could be network, it could be storage, it could be identity provider, many things, right? So this actually allows you to make use of the compute for running multiple databases. Today, if you've worked, I'm sure all of you have worked in some enterprise at some point in your career, and if you request for a new database, what's the fastest you've gotten it? If it's not on Kubernetes or it's not on cloud, what's the not cloud? That's cheating. Let's talk about something that is more traditional. I have a giveaway, by the way. Every time somebody says something, you will get a giveaway. What's 3? 3 months? That's fast? Okay. Well, the thing is that I have seen like even longer than that. But when it comes to Kubernetes, you can pretty much spin up databases very quickly. And hopefully, if I have enough time, I'll probably try and spin up one for you in front of you. So that is one. The second is dynamic sort of resizing. You're able to resize your workload based on your need. If the demand is higher, you can have more. If demand is lower, you can reduce it, make it smaller, and things like those. You have an extremely good amount of portability between clouds and on-prem and all that if you run things on Kubernetes. I'm going to go a little faster because I was there was an issue with the timing, I suppose. And more importantly, it provides you with a very good orchestration for your entire infrastructure. So not just running your application, but connecting to a variety of storage and all. And of course, it allows you to automate a lot of day 2 work. What is day 2 work? backup, recovery, restoration, upgrades, all those is day two work. But anything that has benefits has some downside, right? So these are some of the downsides. When you are actually running things on Kubernetes, you have to be a little aware about stateful nature of your workload, because your application run and your data may not actually end up on the same node. So that's a bit of a problem. You can address those through distributed database. Persistent storage, especially in cases of databases, persistent storage is always a problem, but that can also be something that can be addressed through a distributed database. Another complexity is with the reliable access. So you need to have a load balancing to your application, to your database, even inside Kubernetes. So obviously, if you run it on cloud, you have cloud-based options. If you run it on premises, you have to solve for it. There is also a big networking complexity, especially when you have multiple clusters. So if you have 2 Kubernetes clusters running in 2 different data centers, networking between them is going to be quite challenging, right? So that is something that you have to be aware of. Within the cluster, if your application and the database is running on the same cluster, it's pretty good, pretty easy. So essentially what I'm saying is, don't run database on Kubernetes, run a distributed SQL database on. And that is what exactly Yugabyte is. Yugabyte is a distributed open source transaction-oriented database, which is 100% open source. So, and it's pronounced as Yugabyte. A lot of gotchas or the limitations that I mentioned earlier can actually be resolved by Yugabyte in terms of it eliminates some of the need for external load balancers. Also, it automates a lot of your day two work that you might be running into. Plus, it gives you the scalability. You have more traffic coming in, you can actually increase the number of nodes. And if your traffic has tapered out, you can decrease the number of nodes. You can read and write on all the nodes. Let me just repeat. You can read and write on all the nodes in Yugabyte DB, which is a stark contrast to the traditional RDBMSs. Without compromising the ACID transactions, you are able to actually perform the transactional applications that you are used to with RDBMS capabilities, tables, and everything, and transactions. A small footprint of Yugabyte would look something like this. You typically have a small management console, which basically provides you with the management capabilities, and you have database nodes, typically minimum 3, because it's a distributed system, so 3, 5, 7, those are all good numbers, but minimum 3 is what is needed. Now what it provides, what we have created is the distributed transaction and storage layer, which provides you with automatic sharding and load balancing. And on top of that, a pluggable query layer that provides you with RDBMS capabilities akin to Postgres, and NoSQL capabilities, which are akin to Cassandra. So in a single cluster, you are able to perform both kind of data models with Yugabyte DB. Now, what does a deployment of Yugabyte looks like on Kubernetes? We use stateful set. If you're not familiar with Kubernetes, stateful set is a construct in Kubernetes to run stateful applications. So the ordering of pods and all is taken care automatically by Kubernetes. So we use those. We have 2 sets of pod. One is the master, which is more of a metadata server. Master is a very bad name, because the moment you say master, people go, oh, there is master, so you will copy over. No, it's metadata server. And the T server, which is the tablet server, the name originates from our sharding name. Our shards, every table that we create, we split it into shards. Each shard is called a tablet. That's why tablet server. And you are able to horizontally or vertically scale each of these components. Now, I mentioned earlier, every time we create a table, it gets split into shards called tablets. And these tablets are something that are distributed across multiple nodes. And all the data that you are storing will actually go synchronously, not asynchronously, but synchronously to all the nodes. So let me try and show you a very quick demo, and I probably would have to sit for this. Any questions so far? How much time do I have? 10 minutes? Okay, good. Yes. I am not sure about YDB. One thing I remember from my understanding of YDB was it's based on MySQL API, and we are based on PostgreSQL. And I mean, in terms of replication capabilities, we do synchronous replication of data and asynchronous, like if you are doing it across sites, across clusters. So we can do that. Yeah. Collect your giveaway later. It's here. All right. So let us look at a database that I have running here. So first of all, I mentioned that Yugabyte is can everybody see the screen? Is it legible? Okay. So I mentioned that we actually run pods and stateful sets. So this is my database that is running on Kubernetes, and you can see I have master and T server as my stateful sets, and then a bunch of pods which are running here. So this is similar to the architecture diagram that I showed you earlier. Now over here, what I can do is I can actually run a sample application that will, this is a simple sample application which basically keeps on inserting data into the database. It's a workload generator application. So we'll do that. Now this is like pretty much simple, right? Bread and butter, like this is okay. Now what I'm going to do is I'm going to actually take down one of the nodes of my database, and this application should continue to work without any issues. Yeah. So for that, what I will do is it's tough to actually cause a failure in Kubernetes. So my trick is typically I reduce the number of replicas to 2. Like right now I have 3 replicas. I will reduce it to 2, and let's see what happens. Okay. So I reduce it to 2. Now something interesting happened. So one of the in-flight transaction, right, which was connecting to that particular node that went down, it got disconnected. But rest of the system, it just continued to function. Now, there is a delay of about 3 seconds between the cluster rebalancing itself due to the node failure. So it took, if you see carefully here, it took 3 seconds for it to just come back to a stable state where it's able to look at each other. And we obviously have a small UI to go along with it. And by the way, this is all open source. I'm not using the enterprise version or anything. I'm just using the open source version. This is actually showing you the 3 master nodes, and this is showing you the 3 tablet servers that we have. The one that I have reduced, it is starting to miss the heartbeats now because it's down, right? It will wait for this server to come back for about 15 minutes by default. If it doesn't come back in about 15 minutes, what it will think of is it will declare it as dead, and any new server that comes up would be bootstrapped for data. But in the meantime, my application that I was running, it just continues to run, no problem, without any downtime. I am going to scale this back, and what I should see here is, interestingly, some of the tablets here, there are no leaders on this particular node while it was away, right? Because I mean, it is not capable of serving any data. What will happen is automatically within few seconds, it will rebalance itself, and the leadership role will be restored on the for some of the tablets, for some of the shards. That's the thing with live demos. They can take a while, but yeah, there you see. Automatically, earlier this number was 0, 5/0. Now it's 5/1, and it might get rebalanced to maybe 5/2 also. So this is how Yugabyte DB, because of being a distributed SQL database, is able to run in a cloud native environment like Kubernetes and sustain failures. And it can also provide you with the transaction guarantees, the asset transactions. So that's that. Let me see. Yeah, we saw this particular thing. Yeah, just in case if it was not clear, this is like typically, let's say if you have 4 pods which are running, a table is automatically split into all these shards, and shards are scattered across all these pods. The number of copies of the shard depends on the replication factor that you are defining at the beginning of the cluster. And one of the shard will become the leader for the shard group. So this is how it happens. So all the reads and writes would be done for by the blue tablets, which are basically the leader tablets. All the selection and everything is automated. Now, I mean, obviously, if you want to try it out, we have a completely 100% open source version. We have Docker container. We are able to even run on ARM machines and all. In fact, on AWS, we are the only certified distributed database for Graviton. So if that is something that you want to try, you can try that as well. We obviously have our enterprise offering as Yugabyte DB Anywhere, which provides you with a nice portal for day 2 operation, multi-cluster management capabilities and all. And we have a fully managed cloud offering, which you can leverage for your projects. You can actually sign up for a free cluster today. You can actually get a free cluster for life. Just try it out. And you can actually arrange for a full-blown demo and not like a small 3-minute demo. Just scan the QR code and fill the form, and you get $10 Grab voucher. Any questions? Okay, I'll leave it on that and happy to take questions now.
So I saw a lot of hands.
Sure. Yes, you can use it on bare metal. We actually make it very easy for you. We have a tool called Yugabyte Voyager, completely free open source, that you can use for migrating over from MySQL and Postgres and Oracle. Yes. Third question. Okay, go ahead. You will need to refactor your application, and there'll be a ETL that would have to happen. Yeah. Good questions.
Other questions?
Yes. You first. Yes, if you have an application that is currently using Postgres, it should just work. In fact, you can use the same Postgres driver. We have a smart driver because we are a cluster, right? So like any other clustered database, there is a concept around it, but you can still use Postgres driver also to connect. Yes, sir. Yes, yes. Correct. So yes, we've not solved that problem, right? I mean, the latency, the physics is physics, right? Speed of light is speed of light. But the thing is that in case of like asymmetric latency, say for example, 3 nodes, one is 5 milliseconds away, the other is 10 milliseconds away, then you will effectively be waiting for 5 milliseconds because we wait for majority of the cluster to get the data. So there is that optimization, but yes, we are not immune to underlying network latency. It will become part of your transaction. Yes. Good questions. Yeah, go ahead. Go ahead. Our Helm chart is most advanced, I would say, but we are working on an operator as well. We have an operator, but it's not as advanced. Yes, yes. Yes, so I can give you, like, this is a published study on Yugabyte website with Temenos, which is a core banking vendor. So they have actually managed to get about 450 queries, 450,000 queries per second across 39 nodes in 3 availability zones on AWS. It's their benchmark test, and they said it's about 40% better than what they had. Yes. Your per transaction latency would be higher because of the synchronous replication. Yeah, I mean, what we have observed is ideally we can bring it down to about 3x of a Postgres database, right? But we've even seen, like, you know, because of the synchronous replication, yeah, because the database itself, the writes on the database are not that. I mean, there's no latency as such. We suffer from the latency of the underlying network. If the underlying network has, like, you know, below millisecond kind of latency, which is like local, then you should see like at the most about 3x in terms of a transaction. But of course, we compensate it with throughput. Yeah, I mean, happy to discuss the use case really, because we have seen various use cases where we have been able to actually provide better throughput. Because one of the issues with Postgres you will find is because of a single node master, the number of connections, simultaneous connections that you can do to that node is limited. So you will be limited by that number. But go horizontally, you can at least increase the number of connections. Yes. Yeah. There's no exclusive lock. We are a lock-free database, first of all. Second thing is, if your query commit has finished, the data has resiliently stored across the cluster. Like right very next instance, like your commit happened on, and obviously under the hood we are using SS tables and mem tables, right? And we have a wall log. So it works is it goes in the wall log. If the node crashed and if it comes back again, it will reprocess from the wall log, right? If it has not gone through. But the point is that if the commit has happened and the control has gone back to the client, then that has resiliently been stored. Some other shard which will take up the leadership role will now have your latest commit. So, in fact, I did not mention it in the presentation. We practically have a 0 RPO. Like absolutely no data loss in face of a failure. If your transaction is committed, the data will not be lost. And RTO is about 3 seconds minimum. Yeah. No, that's for the portal. Yeah. The configuration of the database obviously would, I mean, that was a minimal configuration, I would say. But depending on the number of transactions that you're looking for, the amount of workload and all, configuration would be bigger. Any more questions? I still have 3 more things to give away. Please. Yeah. Yes. Yes. Exactly. Yeah, you do not, the application doesn't have to worry about which server do I connect to, and no, none of that. That, I mean, being an app developer, like that for me is a big boon, you know. Like not having to bother about which server to connect, which cluster to write to, and all that, none of it. Just connect to any one of the nodes, write the data there, and it will be there when you go there. Okay, are we out of time?
Okay, I would say let's thank the speaker here. We have
Fun
a
is for
bit
you.
of time till oh, thanks a lot. I get also something here.
Yeah.
We have to start here at 45, so you have like 8 minutes or something to either grab a coffee or take whatever you have to do. Also, ask further questions if you want. Thank you. Sorry, I cannot correctly. Just Hong. I'm very careful with pronouncing names because my name is very difficult to pronounce, and I live in a strange country. So I'm used to it. So Hong is from Datadog, and I think a lot of us, if you're in any way related to cloud or logging, then we use Datadog. So observing those data pipelines, great topic. And thanks. Welcome the speaker.
Thank you, Norbert. Thank you. Just a show of hands, how many of you are SREs? Wonderful. Developers who build stuff in Rust? That's a curveball, and wow, you caught that one good. Data pipelines, anyone built one, seen one recently? Anyone heard of data at all? Of course, thank you. So that's how we'll start. We'll talk about observations, observabilities of data pipelines. Yeah, my name is Hong. I'm a sales engineer from Data. This is how we can keep in touch on social media and emails. So we'll start with a best practice. How do you monitor data systems today? One of the key things to note is that you'll be looking out for some of the SRE golden signals, if you like. It starts off with latency of your system. How much lag is your system encountering as a result of a voluminous amount of requests sent to the system itself? Errors, what's the error rate like? It's good, it's healthy, tolerable, within a range that you could manage. Traffic requests, so basically saturation. How saturated is your system utilization wise? Basically all indicating the health of your application. So one of the key things about data of the systems that you observe is that it's huge. That's why we call it big data. You want to get more of your observed data, and that's where the concept of a pipeline might actually help. Now the evolution of the pipeline has got to a stage where now you get full empowerment across the departments in a organization, multiple personas can actually be affecting changes to the data pipeline. That's right, your sets of observability data could have different players, different data players, different personas, interact with it, perhaps transform it, enrich it. Nothing new, because you may have heard of Kafka, you have heard of Databricks, you have heard of quite a lot of data lakes, for instance. And we talk about this. But it takes something to basically put together a observability platform that is capable of observing those key signals that we talked about a slide earlier. At the same time, allowing empowerment of different departments that will interact with the data sets. All in all, the whole idea is to improve quality control on the data. And you can see the example shown here, Kubernetes clusters being observed, streamed across different departments or having different personas in departments have a say in terms of how they want the data to be manipulated, used. We'll see a demo of that shortly. And here's an example of why that sort of philosophy actually helps in observability today for the benefit of SRE projects. It's called democratization, democratizing the data platform itself, where you will have a means of, say, the security team interacting with other SREs of other backend teams, such as this example portrays, making changes, manipulating the changes. It could be just simply tagging certain data sets and saying that this is a result of having a very unsecured, vulnerable app. That's what the security team does. And then there is the governance, risk, and compliance team that could categorize this, put that into the data warehouse, make it easy for other teams to reference, to visualize it in their own dashboards. So introducing a open source technology, courtesy of Datadog. It's called Vector, and we provide the source code, the link to the source code on GitHub in a short while. The whole idea here is, regardless of the sources and the sinks, your endpoints, Vector is a easily configurable, installable, deployable pipeline, and very importantly, also highly scalable. A huge amounts of loads, the likes that Comcast, T-Mobile, and Zendesk have actually experienced. The Vector was able to deliver. So Vector is that data pipeline that a lot of personas might be looking forward to interact upon. One key thing about this is because it's from Datadog, we love our own dog food. So Datadog being a leader in observability, the go-to observability platform for the SRE today. We like our log management. We like it a lot. So does our customers, the community, the SRE community. So it's highly encouraged to use data log management hand in hand together with a open source observability pipeline built on Vector. So Vector comes with the concept of transformation and enrichment of the data sets. Very importantly, also it comes with a concept of an aggregator. We'll see in the next few slides example of how the aggregator works. The aggregator basically allows multiple clients, agents, some of which from Datadog, some of which are from other observability tools. They could be streaming all that rich observability data into the transformation pipelines, so as to speak, at stage 2. And then keeping a record in different kinds of sinks. It could be Splunk, it could be a data lake, it could be any sort of data schema that Vector understands. So there's a long list of sources and a long list of sinks that the Vector aggregator is able to connect. Here's an example of more possibilities, the topologies. So we could be literally storing it into AWS S3, block storage. I mentioned some of the community favorites, Kafka, Loki, Elasticsearch, all of which could be potential sinks after transformation of the data that originated from the usual push sources like Logstash, Prometheus, StatsD, Syslog, has been converted, enriched, transformed. It could be even condensed prior to storage in all these things over here on the right. All in all, highly load balanced, highly available, scalable as well. The concept here is that pipelines for everybody, for every kind of use case. Let's take a look at the demo. So over here are examples of some of the pipelines that have been built. Whenever we visualize a pipeline, the different stages of the data transformation, of the data enrichment is really important to the SRE. It's really important to the different personas. Remember the security team, the GRC team. So it makes sense to perhaps look at error rates. Like, are we getting all, because this is huge amounts of data being streamed. At every single stage, are we having a transformation issue? Some of the data not being enriched appropriately. And then we can also see not just errors, we can also see the throughput. I'm just going to rewind that again. There we go. So you could see throughput, you could see number of events that could potentially also indicate health of the different stages of transformation. We could look at the utilization of that particular stage of the pipeline also. And very importantly, also diagnostics. At real time, whenever there is an issue with transformation of data sets, those diagnostic logs pretty helpful. Very importantly, also get a feel using a field gauge, like how much in terms of the event flow is actually occurring over here. And very importantly, also would be, as you can see over there, way at the top, a capability of transforming the data based on the different sources. I can see at the get-go, some of the sources are pertaining to one of our favorite agents, the data agent log, and we're transforming it based on individual key value pairs. So log transformation, that's another use case. Very importantly also, eventually it leads down to simple log management. And you can see that from a perspective of logs, like I mentioned, we really like log management, just like the rest of customers. We could use that to pass through any amount of enriched and transformed vector observability pipeline logs. Take that, analyze it, and eventually even go into metadata, know where it actually comes from, which particular components were involved. Very importantly, also, which level of detail do you actually want? One key thing would be context. From a contextual standpoint, you could even locate exactly where in a log stream, a particular identified log entry that has been picked up from an observability pipeline. You can dive in deeper using data log management. So with that, we're back to presentation slides. Now, Vector doesn't live alone. It is part of an observability platform that is the leader in the industry. It's a platform that provides you with insights into usability, observability driven by AI as well. Very importantly, there's the freshness, the accuracy, the durability, and the coverage that this platform delivers that makes it a whole lot easier for SREs to do their work. Very importantly, because it's a unified platform, economies of scale, 16 technology pillars all on one single platform, ranging from mobile user analytics to browser-based analytics, browser-based apps analytics to security analysis, posture management, security posture management, very importantly, log management as well, and also application tracing. All in all, smart tooling all in one platform. Here's an example of what you could potentially do with 16 pillars all in one. With the power of Vector, helping in terms of observing huge data sets, and that is root cause analysis within the power of your fingertips, your mouse clicks. We could dive in really, really quickly using Datadog with Vector to analyze data with regards to each of your deployed applications. This is deployment tracking, where we could actually dive into the various signals again, error rates, latency, saturations, picking up on in terms of issues every time any of those signals like latencies get too high. Here's an example again, all I could be doing with huge amounts of data could be streamed over observability pipelines, and that would be some of that data correlate to application traces. So you have that data in log format correlated with application traces and visualized across the span of your modern application, which could be a mirrored network of microservices. All in all integrated, making whole lot of sense to use a platform to investigate if there were any outages that in the moment you see within the application flame graph that is indeed a module, a method call that has failed. And then dive into those logs that the Vector has streamed to, say, Datadog. And using Datadog to analyze a whole lot more of what this modern application is actually facing. So Datadog is the unified observability platform. Did you know it's also a very, very big data pipeline? So going back to the theme of this presentation again, let's take a look at what's underneath the covers. From the agent to the ingestion buffer to the individual aspects of the processing capabilities of Datadog, it's a pipeline. It's a huge pipeline with time series database storing all the metrics, traces, and logs, what we call the 3 pillars of observability. From that standpoint, it's easy to build a dashboard on top of that time series database. We support 22,000 customers using millions of hosts. Collecting 10-second snapshots. Yes, sampling is supported. So 10 seconds seems to be a popular sample time window of trillions of events per day. And very importantly, this is what the pipeline will look like potentially for a cloud administrator, for SREs who uses the 3 pillars approach, metrics, traces, and logs to analyze outages of their application or system issues or performance optimize them. Very importantly, the CISO's department, the CISO -1, will have a role to play using such a platform technology, and that will be being able to analyze the security posture of their cloud-native environment, monitor the health from a security standpoint of their workloads and their applications, and visualize it in such a manner where you have what we call a huge map of all your assets, your microservices assets, databases, and we could potentially be pivoting from one particular service to another really, really quickly, thanks to a concept known as Unified Observability Platform. Now, from a perspective of AI-driven nature, that big data pipeline called Datadog actually helps also to analyze critical failures, perform the root cause analysis across such huge amounts of data, and also the frequency of data changes. Very importantly, this is DevOps-centric. The concept where we can actually be profiling the health of your application, dive into perhaps the CPU time per minute at each level. So imagine if you have been doing DevOps all the while. DevOps talk about continuous innovation and integration, rolling out incremental changes to the code. The challenges is every time you have those new features rolled out, can you accurately determine how well the particular module is performing? So again, a concept of having a really big data pipeline that Datadog is built on top of, well, it's possible. It's possible. So in short, download Vector today, right? Kick the tires, try out different deployment topologies. This is what you get when you visit the GitHub repository, officially where the Vector agents, the source code is made available. There are components listed. There are guides listed as well, how you would be deploying it for use case A, use case B, use case C, and so on and so forth. Some advanced use cases worth mentioning very quickly before we end. Kinesis Firehose or log forwarding. So you have ingesting our cloud logs into AWS Kinesis Firehose. Can you make sense of those logs really quickly? Vector can help. Could you merge multi-line logs or Lua, one of the favorite programming languages when it comes to web infrastructure? Nginx is built on Lua. So could you do that? So the answer is yes. So this is really where you would want to start getting more acquainted with Vector. It's repository, and here we go. github.com/vector.dev/vector, as well as there's a blog and a quick start documentation as well, all here on the slide. And if you have any other questions, feel free to ask me right now, or you can drop me a mail.
Let's thank the speaker for the very interesting talk. So any questions, very short? I think they are long.
Right, thanks for that. Didn't really mention that, but great point. It came from originally a company called Timber.io. So Timber is now part of Datadog. In the spirit of this, I guess the conference, we will show you that Datadog continues to support the open source community. Datadog, did you know, was an open source technology company at the very, very beginning. Yeah, so Datadog was open source. So we have multiple open source projects. Vector continues to be one. Well, I guess I can't quote in terms of the business direction of the whole company, but we continue to serve our customers. It's something you do very well, and I think our customers appreciate it. And Vector plays a huge, huge part in our observability platform strategy.
Any further questions? Well then, thanks a lot.
Thank you. Thank you, everyone.
Thank you. Hey everyone, so today I'm going to talk about DevOps. So basically about how we do quality at GitLab and few things which could be would be useful for you as well. So yeah, so these are the few things that I'll be talking about. Yeah, shifting left is something that most of us would have heard. So we'll talk a little bit about that and about continuous testing. So what do we exactly mean by continuous testing and how continuous can it be and from where could you start this continuous testing? So these are a few things that I really want to talk about. Yeah. So a little bit about myself. So I'm with the quality engineering team at GitLab. And yeah, I'm passionate about designing and developing test frameworks and tools. And simple yet powerful is something that I totally believe. Also, I'm with the Women Who Code Chennai chapter. So Chennai is a city in India, and I'm one of the directors there. And I'm really excited to see the other communities from other parts as well. All right, so yeah, so GitLab, I'm sure most of you would have heard of GitLab, right? So it's the DevOps platform, and yeah, it is cloud agnostic. You could use it in your own cloud providers, and yeah, it could be self-managed, or you could also go with the SaaS solution as well. Security, compliance are all built into the system, and yeah, open and always improving. So the main GitLab, it actually works on open core model, wherein like the community edition is actually open source, and the enterprise edition is actually open core, meaning like all the code is available to you, and you can actually read as well. So yeah, so these are various features that are there in GitLab. I wouldn't be going through all of these, just wanted to give a snapshot of what are available, the various capabilities that are there at GitLab at every stage of the SDLC. Yes, so to talk about the it wouldn't be complete if I don't address the contributors as well. So we have around 3,660 open source contributors as of today, and around 2,000 plus team members across 65 countries. And yeah, so mentioned here a few open source partners. So you can read more about what it actually means to be an open source partner. There are a few benefits when you are an open source partner. So you can read about it more here. So I thought it would be relevant to mention these details here, given it's all about open source. And yeah, and there's also this program called Open Source Program, which is actually, it also has few benefits, meaning like if the project is a qualifying project, then you get to use the GitLab Ultimate features. And yeah, there are a few other benefits as well. So again, you can either Google about this, or you could even contact the email mentioned here. All right, so getting into the topic for today, so this is about dev test ops. As I mentioned, when we talk about DevOps, we often hear this word called continuous across every stage, right? So continuous development, continuous testing, continuous integration, deployment, continuous monitoring. So my focus here would be on continuous testing. So as you see, like there are multiple tools that could be used across different stages to attain these things. And so when we talk about continuous testing, like how continuous can it be? So for example, if you see in this DevOps cycle, right? So you have a stage called test. And so what does it actually mean? Does testing come after a particular stage, or does testing happen across different stages? So that's something that I really want to emphasize on. And before we get into it, I just wanted to talk a little bit about this shift left. So have you heard of the term called shift left? Yeah, so basically it's about shifting the testing left, right? So it's all about failing early on and failing fast so that you get the feedback faster and you improvise on it earlier. So that's what this whole thing is about. So, so what does it mean? So from where can I start testing? Can I start testing right from the plan stage wherein the requirements are being discussed, and or can testing be done at a design phase itself wherein the UI and UX designs are all discussed? So where is the appropriate place to start this testing? So these are few questions that we'll answer as we go through the various slides. And yeah, when we shift left, there are a few benefits attached to it as well. As I mentioned, failing fast, early detection of errors, and yeah, it's cost effective. And yeah, those are a few benefits when we shift left. All right, so dev test ops is all about ensuring quality early on and at many points as possible. So as you see here, we test at different points in different ways. Maybe it's not exactly the same way how we test at every stage. It might not even, you might not even, it might not relate to test cases per se. Actually, what I mean by testing, it's ensuring quality is what we are talking about, right? All right, so the step 0 or the bare minimum that needs to be agreed upon by the team members is that quality is everyone's responsibility. It's not, it no more lies in the hands of the quality engineering team or the testing team or whatever it's called. So quality is everyone's responsibility is something that all of us should agree upon, unless this is, I mean, this is a change in the mindset, right? So I think without this, I don't think we could achieve what we are trying to with all of whatever tool is being used. Yeah, as mentioned here, quality is a continuous process. It's no more a phase in SDLC. So yeah, this talks a little bit about what we do at GitLab. Yeah, 3-enable process is something that that most of us could be aware of. So this is about involving the various stakeholders during the initial phases, during requirements analysis and stuff like that. So yeah, the product team, the quality team, and the development team, they come together and discuss about it. And don't be afraid of what you see here. About this is actually the Tanuki based on which the GitLab logo is based on. So yeah, so as you see here, like there are 4 different stakeholders who are involved in these initial discussions, and we call that process as the quad planning process. So yeah, these are a few things that we do at GitLab. And the tools, as I said, we use GitLab to build GitLab itself. So yeah, the GitLab issues, milestones, epics, and there are features specific to planning. So all of those are being used. And yeah. And can testing be done at the design phase? I think yes. So that's something that is done here as well. So we have this feature called design management feature, wherein the designers, the UI and UX designers, they could add their details to the GitLab issues, and the other stakeholders could actually collaborate on the issues itself. So this is a way of getting the quality engineering team involved and in the discussion itself. All right, so when we move on to the code, we build the code and build the code, and during code review, like there are certain features. So basically, we need not think of, I mean, we could ensure quality not just by means of testing and test cases alone, but by various other features which could be part of your CI pipeline itself. So that's what I'm trying to emphasize. So these are a few things like code coverage feature is again available in GitLab, and I'm sure like we could incorporate it in any other CI pipeline as well, wherein we have gens and NPM modules which take care of code coverage, and they could be used the CI pipelines to ensure the quality. And yeah, so static code analysis is another way of ensuring the quality of the code itself. Again, the example that I mentioned throughout the slide is all that's used in GitLab, the various features that are available which enables quality at different stages. But again, this need not, if you're using any other CI pipeline, it could actually be achieved by the various other modules that are available as well, and it could be incorporated into your CI pipelines. So yeah, as you see here, so this is a snapshot of the MR widget. So MR is merge request. In GitHub, it's called pull request, right? So it's an equivalent feature here, and this widget contains, I mean, it could be configured based on what you need to see in the CI pipeline, and the MR widget, it could actually show the quad quality and the degradation in the quality of code as well. And yeah, accessibility testing is again it could be again configured in the CI pipeline, and these could be actually added in the MR widget. So what I mean by this is that even before your code could be merged into the next stage, maybe into the mainline branch, you are ensuring the quality of your code itself, right? So I think that is the biggest advantage. You get to see all of these defects or failures early on. Yes, security testing is again possible. You could actually add that to your CI pipeline as well. And yeah, again, this is an example from the MR widget again. So all of these are configurable in your CI pipeline. If you're using GitLab, then the GitLab ci.yaml could be configured in such a way that all of these are enabled and run every MR request, merge request. All right, so apart from all of these features that helps in ensuring quality, yeah, of course, we do have end-to-end tests and other tests which helps in ensuring the quality as well. And testing pyramid is something that we follow and we try to adhere to. Unit tests are non-negotiables. No feature is complete, or it cannot be merged without a unit test. So that's something that we have as a non-negotiable thing. And end-to-end tests are more of journey tests, wherein it doesn't test every detail of a feature. It's more of a blanket which tests the user's journey from end to end. All right, so yeah, so apart from this, yeah, at the release stage, how could you ensure quality? Of course, we do have tests that are run in different test environments as well, and these are reported through the Slack channels. Again, this is a very useful thing wherein you can add it to your way of collaborating within teams so that it helps in quicker access and taking I mean, it helps in better monitoring as well. And yes, sanity tests are run again on production environments, and also we do have tests run on a subset of users alone. And of course, the feature itself could be controlled, meaning like we do have feature flags which helps us to deploy it for a percentage of users, and it could be increased. So that's something that helps in better quality as well. And in terms of exploratory testing, we do have some, there's a feature called review apps, which I didn't mention here, but it helps in spinning up a dynamic instance even before your code is actually merged, even when the code is in the merge request stage. And during code review, you could actually spin up an instance which has your code plus the current state of code itself. So that way you could do some sort of exploratory testing, and you can take a look at how your feature is actually looking even before the code is actually merged to the main branches. So that way it also helps in the quality of the code. All right, to summarize, all that I'm trying to say is quality is everyone's responsibility. And I think that is the mindset that we need to have and work towards it. And then what is the responsibility of quality engineering? Quality engineering is actually responsible to facilitate this testing and quality at every stage. And yeah, and testability is something that all of us, right from the designing and the development phase, everyone should be mindful of to build a product in such a way that it is easily testable. And yes, quality should be baked at every feature of the pipeline itself. That's pretty much it. Any questions?
Okay, let's thank the speaker.
Thank you.
And think of time for questions.
Yes. yes, the issues are used throughout the life cycle, wherein the issues are used for the initial discussion as well. And again, if, as I said, like GitLab is fully remote and or most of the discussions happen async, and having it all in the issues, it facilitates this as well. And it doesn't end there. Of course, we do have the other features mentioned there as well, right? The milestones and epics. So milestones, basically, we have a monthly release. So milestones help us to plan the upcoming releases as well. And all the, and also there are features specific to release, like wherein you could just tag a release and pick the changes that you want to release. So all of that happens based on these issues. So all the features are actually tied. The issues are used not just for discussions, but it's used until the end, until the code is actually deployed. You can, when you take a look at the issue, you will see the complete state. Like we do use labels as well. You can see the different stages through which it has gone, what state it is in. Is it in the planning phase or in development, or has it been deployed and stuff like that. Sure.
How do you just mentioned labels. I noticed with us that we far too many labels.
Yeah.
Very chaotic. Do you have any strategy on how to do
Yeah.
labels?
Yeah, I have my colleague here as well, Albert. So yeah, that's something that we constantly keep trying to. So in labels, there is a specific type of label called scoped labels, which actually has helped us a lot. Meaning, like for example, if there's a bug, you want to call it a bug, but there are different stages in bug, right? Maybe it's a valid bug, or it's a bug, but it would won't fix bug and stuff like that. You could actually have scopes on kind of a label within a label kind of thing. So those scope labels has helped us. And yeah, I think that's one of the main things that comes to my mind. Yeah, label hygiene is something that we constantly keep working on.
Okay, well done. If you have a question, please thank the speaker.
Thank you. Thank you.
Thank you. Hello, everyone. Today I will talk about managing workloads on multiple Kubernetes cluster using FOSSASIA and Cluster API. A little bit about me. My name is Chiến. I work in Viettel Group, a giant telco in Vietnam. I have over 5 years working experience in cloud area. And I'm currently working on development cloud solution for Viettel's public cloud services. This agenda today. In Viettel Group, our public cloud services heavily is based on the open source projects like OpenStack, Kubernetes, and maybe Prometheus. The Kubernetes related product were built on top of Cluster API. That is the infrastructure service as an infrastructure provider. So in the past one, I will highlight some key point about Cluster API. In part two, by default, Cluster created by Cluster API is minimally functional. For instance, they do not have a container networking interface or CNI for short, which are required for port-to-post networking, or any storage classes which are required for dynamic persistent volume provisioning. User maybe manually add the component to every cluster they created. We can guide our user to manually install the component with some script or manifest. However, that manually process can easily introduce issue. We must have a mechanism to apply an initial set of default resources after Kubernetes cluster are created. It's make cluster created by Cluster API functional and ready for the workloads from the beginning. In part two, I will present about automation and managed workloads in Kubernetes cluster. What is the Cluster API? Cluster API, the Kubernetes project, yes, enable the declarative management of Kubernetes cluster. It provides us custom resources and controller that can be used to create, modify, or delete cluster. For you who don't know custom resources, custom resources is the way we can extend the Kubernetes API. If you guys are familiar with Kubernetes, you may know deployment demand set. The own Kubernetes building resources. So if you want to extend Kubernetes API, you can develop your own custom resources for your own purpose. So why we use Cluster API? Managing Kubernetes cluster can be a complex and time-consuming task. So with Cluster API, you can automate the process of creating or managing the Kubernetes cluster, make it faster and more reliable. You can also manage cluster consistently across different environments such as development, test, staging, and production. How Cluster API work? Cluster APIs work by defining creating custom resources that represent different aspects of Cluster, such as control plane, worker nodes, or networking, or storage. Um, those, those custom resources are used to declare the desired state of Cluster. So sets of Cluster will reconcile the actual state of a Cluster to the desired state, the desired state of those resources. So let's take a look at some key components of Cluster API. Here we have Cluster API controller. This is a core set of resources that define Cluster API, such as Cluster, machine deployment, the bootstrap provider is responsible for generous bootstrap resources to bootstrap control plane or worker nodes. Here we have infrastructure provider. The infrastructure provider will be responsible for creating, manage the actual the infrastructure that the Kubernetes cluster will run on, such as virtual machine, load balancer, and etc. And here we have control plane provider. It's responsible for bootstrapping a control plane provider. So, what is the benefits of using Cluster API? Here is a few. The automation. Cluster API will allow you to automate the process of creating and managing Kubernetes cluster, reducing the time and effort. The consistency. With Cluster API, you can manage cluster consistently across different environments, reduce the risk of error, and ensuring that your cluster will set up correctly. The third is flexibility. With Cluster API, you can use different bootstrap provider, control plane provider, infrastructure provider, and give you more flexibility on how you set up Cluster. You can see you can run your Kubernetes cluster in any provider like Google, Amazon, VMware, etc. You can even develop your own infrastructure provider to make your cluster run on your infrastructure. So, how did we automatically install an application on remote cluster? Cluster API introduce cluster resource set, custom resource that will be responsible for applying a set of resources defined by the user to the matching cluster. But using cluster resources, we find it's not very good solution because the support applying YAML files, but it don't help you control the whole life cycle of application like delete, update, upgrade, etc. So we find flexibility the matching solution with Cluster API. So flexibility Kubernetes native continuous delivery tool that automate the deployment of application and infrastructure to Kubernetes cluster. It provides ways to manage the lifecycle Kubernetes resources across multiple clusters. So in Flexity, we use ham charge controller. Ham charge controller is a component in Flexity that manages ham charge on Kubernetes cluster. It provides a way to deploy and manage application using ham charge. So let's take a look at some of key components of ham charge controller in Flexity. Here we have the ham repository. Ham repository is a resource that represents actual ham repository that contains actual ham charge. When a ham repository resource are defined, it specifies an URL that points to the repository where the ham charts are hosted. The Flexity can use this information to periodically sync the ham repository and make the latest ham charts available for installation. Here we have ham relay. With also custom resources definition that we use to define configuration for the ham relay. It used to manage the deployment of ham chart to Kubernetes cluster via ham actions such as install, upgrade, uninstall, rollback, or test. So, push Cluster API and Flexity all together, you will have a system that can manage multiple Kubernetes cluster and workloads running on them. So let's take a look. Look at the workflow for doing ham charts in Flexity with Cluster API. So here we have an uncentralized repository. The developer can create a ham chart for the application and put it to this repository. After that, Kubernetes admin can create a ham repository object that define the URLs pointing to this actual ham repository. So the source controller will predictably sync the information of ham charts into a local repository in management cluster. The operator will create a cluster object. So the cluster API controller will reconcile it and provision and bring up a Kubernetes cluster running on the rise. To install some needed application, the operator will create the ham release corresponding to each application that contain they contain information about the secrets, pointing to the Kubernetes config secrets, pointing to the remote cluster being generated from cluster APIs. The chat information, the version of the ham chat, the ham action is maybe install, uninstall, upgrade, etc. So the ham chat controller will reconcile this object and prepare ham chats and install the application to the cluster. So let's take a look at what's in the custom resources. In cluster, I highlight some important field. It's maybe cluster network. It defines the network configuration of the cluster, the control plane ref, the control plane reference. It refers to the objects. Another object that the control plane provider will reconcile. The infrastructure reference that's point to an object that the infrastructure provider will reconcile. With this object, the cluster API will bring up a cluster on the infrastructure that the cluster reference. Here we have Hamley. As you can see, it will have the Kubernetes config reference. It refers to the Kubernetes config to the remote cluster that the ham chat will install. I can see the chart, the version, the source reference. It refers to the ham repository. You can see the packet namespace, the storage namespace. This is the namespace the ham chat will install in the remote cluster. In the ham repository, you can see the URLs that point to the actual ham repository. So, in conclusion, Cluster API is a powerful tool for managing cluster in declarative approach. The Cluster API will provision manage Kubernetes cluster, but Cluster API is minimally function, not ready to use. So you need using Flux CD with Cluster API to effectively automate the process of managing workloads in Kubernetes cluster. So, thank you for your attention. Do you have any further question? If you have any question, you can drop me a mail later.
Do you provide some tools for what you showed us a lot of YAML files to send over for deployments? Do you provide any additional tools that, because from my experience with deployments, YAML files always contain errors. Because people write them. That's the reason why a lot of people switch to Q sheets, because they are much more, at least a bit less verbose. So I would be interesting to see, I mean, especially with multi-cluster deployments, I would be really scared to do myself once. How do you deal with that?
You mean how how I prepare the last month YAML file.
Yes.
Yes, I will package in Helm charts to easy to install.
So you rely completely on Helm and without writing yourself the YAML files?
What what do you mean? I don't.
I just have seen too many wrong deployments,
Yeah.
but incomplete deployments, because the YAML file that was used for deployment was just not what it should have been, right?
Yeah.
That can always happen. That can happen also with the files you showed us, right? So is there, within FluxCD, is there any safeguard for this? Is there any way to improve on how to create deployments and by definition of deployments?
I will discover more and answer the question in the mail. Okay.
Well, we can take this offline.
Thank you.
Any further question? Yeah, there is another question.
Yeah, just to add on to what you said, basically, I just wanted to give you some feedback, and this is what my talk is all about tomorrow. So what he's asking is basically, do you provide some syntax support or definition support or hover auto-completion support when someone is trying to write the YAML file on a code editor? This is what he meant. And probably this would actually save a lot of wrong configuration to be pushed. And so what I would suggest is take a look at the language server protocol that Microsoft and Red Hat together have released recently, so that you can provide all the supports for your configuration files. And people for different code editors can use those language servers and can write a proper configuration without even they can be sure that the configuration is at least correct before having to push the thing to the cluster. Yeah.
Yeah, I agree with your comment on language choice, but language choice is only one part because it doesn't guarantee completeness, right?
Yeah, of course, but that's just a part of the solution.
Yeah, but it is one, yes, I agree, it's one part of writing. Yeah, good comment, thanks a lot.
Thanks a lot.
Any further questions or remarks? Are there not, then let's thank the speaker. Thanks for the presentation.
Thank you.
Thank you. is here. It's already late and we are all tired, but looking for the party tonight. So let's enjoy a last talk for tonight. It will be great, I'm sure, about QA automation. Please welcome our speaker.
Thank you. Thank you. So thank you everyone for staying so late. It's the last. I wouldn't be promising like I wouldn't be taking a lot of time here. And thank you for Ramya covering most of the testing strategies. So I would be just skipping it out. Thank you, Ramya. So my name is Rohit Vyas and I'm State Quality Engineering Manager at Red Hat and mostly involved with the automation part of the CI of our test suite. So this talk is mostly about revamping the QA automation pipeline, QA automation testing using Tecton pipeline. This talk is mostly about my journey towards like how we integrated our integration testing from end-to-end point of view. If you look around the QE/CI process, and if you want to think about the CI and CD process, so it's like building your software automation from building, deployment, building, testing, and deployment. But what I'm talking about is just the CI process of the testing side. And this CI process of testing side includes from identify at what stage your test suite would get triggered. Then it from what repository you are using the code to be checked out. It could be GitHub, it could be GitLab. You need to also lint your code. You need to ensure that you coding like JS, if you're using JavaScript, you need to use JSLint, Python, you're using PyLint, YAMLint, depends on the code which you are using for your integration testing. Then you have a provisioning environment where your SUD will be run. What is your provisioning environment, whether it would be a cloud, it would be a bare metal, what kind of provisioner tool you're going to use. It in integration testing, some might be using Ansible as a provisioner, some might be using Terraform. It totally depends on the set of tests which your test engineers have built. The SUT setup can be in AWS, GCP. It could be a standalone bare metal machines using Vagrant or Libvirt or something like this, or maybe it's running on the Podman containers. So that's the SUT part. The test execution consists of your Ansible test, your Python test, your JMeter for the performance, your API test would be in SOAP, or it would be running on the headless mode with using the Postman, or it could be a Go for the Go framework. The last part, not the last, but it's a test logging, because that's the most important part where your stakeholders are keeping an eye on. The logging part and the analysis part. That's also a very interesting part, because what everyone care about is what's the percentage of your test cases passing and what's product readiness for your entire workflow. Last but not the least, the important part for getting the notification, your notifications should be very proactive at any point of time where your test execution get failed, or there is an identification of any deviation from your workflow, and you can have your test notification integration with your Google Chat, Slack, or even getting a PDF reports on the Gmail. So this part is just a small criteria in the CI/CD workflow where QE/CI scenarios and the workflow fits in. There are so many CI tools available. It's pretty hard to identify which one suits your requirement. There's like Jenkins, where you can write your Jenkins files. You can grow up into multiple stages, build up a pipeline of these steps. You have GitHub Actions, which is good to integrate with your Git repos, where you have to integrate your, where you have to run your some kind of action files for your integration test. You have Argo workflows, where you can run your execution pipeline on multiple clusters by integrating to it. And then you have Tecton, which I am trying to target today. So Tecton pipeline. So Tecton is, so just to give a brief introduction, like Tecton is a Kubernetes resource which helps you to build your pipeline using multiple tasks and stages, multiple tasks and the pipeline. This is one of the use cases which I was working for my last project. We were certifying an operator certification use case where we need to certify different vendors, operators, and also we need to certify different OpenStack plugin. And we have like tons of different test scenarios that we need to cover on. If you see that there are like proper triggers, it could be triggering our test suite twice in a day or probably on every Git check-in. Then we have to check out the workspace. That's definitely a part of our CI part. Provisioning and building a test data. Provisioning on multiple environments like OpenStack. Then configuring, setting up a OpenShift cluster. It could be using a Minikube, code-ready containers over a bare metal machine, or it could be using just Kind cluster. Deploying and configuring the operator side of it, triggering the GitHub Actions pipeline, which is on the upstream side, pulling the events notification from the GitHub comments just to start and initiate our integration test suite. Integration test suites were in many different formats, from UI tests, which were in Cypress, the backend test, which was on Python, the API test on Go, then we have Go catalog test, we have tests which certify different Docker images or the container images, then we have backend DB tests, and this has to be integrated on together. It requires all configuration, so we have bundled all the tests in a container format, container image, and we keep those container image in a registry just to ensure that we are well versed with the latest images for our test suite, as well as it has a vulnerability scan, so we are always updated over it. A vulnerability scan on currents with clear services, so it's like quite giving us the updates of the health of our images. The last part would be the logging part. We push the entire test results into our centralized data logger, which is report portal. We are using report portal for pushing all of our test artifacts, test reports, the UI test logs, everything. And then after that, we have notification section where we push all the notifications to our Google Chats, Slacks, and Gmail. Just to bring a light introduction about Tecton CI. So Tecton CI is a Kubernetes resource which help us to build up our pipeline. And by pipeline, we have multiple areas. The smallest one or the shortest one would be the steps where you execute your commands and your test scenarios bypassing the arguments. Then we have a task which bundles the steps. After a task, you can imagine as different stages of a pipeline. A pipeline is also a Kubernetes customer resource, which is used to bundle and execute your task, whether you can run it sequentially or you can run it parallelly. Pipeline runs with a pipeline run custom resource, which is then been triggered by a trigger template. You can bundle it with the trigger template. Trigger template is something which listens for the trigger event, and you can listen those trigger event with the event listener services from the Tecton, which helps you to listen different triggers like from webhooks, or you can just directly use cron triggers. Why we shifted to Tecton? Because most of the workload which we were running was run by container side, because our tests bundled on container. It was easy to use the same format where we can just execute our container test scenarios. Also, our applications can be deployed on the same cluster, so that was easy for us. Then Tecton provides a good mechanism of executing using CLI and GUI. So Tecton has a CLI client which is called TKN. You can use it to run from CLI. It's easier to integrate, and it also provides a GUI dashboard from where you can just manually run the test on demand. Then we have a huge benefit of using Tecton was that it's catalog source, where you have a predefined task which you can just directly integrate with your pipeline. It has a huge community, and the best part is like its tasks are reusable. So you need to write your task once, and you can reuse it in multiple pipeline scenarios. Also, Tecton tasks and pipelines are just YAML. You can write your YAML over here, defining what steps you need to execute, the images on which your task would run, and each task run as a pod, and each pod executes as a single instance for the process. So you define your task in a simple YAML format. It's easy to understand by QA engineers, or it's easily maintainable because any changes on the test side will reflect on the image. So you can just update your image. It's quite easy to integrate in the entire format. Then you can integrate those tasks on the pipeline, which defines whether your task would be executing parallelly or sequentially on a specific time. Then you have a pipeline which defines how your pipeline, you have a pipeline defines how your pipeline would trigger. You can pass all the arguments as the input and the output resources. You have a trigger template and event listener for, like, if you want to create an event listener for Git events, you can have it as a Git event with which respect to the push hook or something like this. And also you can integrate it for different, like you can use it as a webhook, I think in GitHub Actions there's a HTTP response dispatch workflow, so you can also trigger your event listener directly from any HTTP request. All right, I think this is a small video of Tecton catalog where you can just directly search for your task and let's say you want to create a task for a PyTest. One example, you can just directly go in the PyTest, download the task. You can download the task, go in the CLIs, you can install the task, give a reference of your task to your pipeline. You can directly install the task in your cluster. You can give a reference. Once you have a task in your, it directly installs the task in your Kubernetes cluster. And once it's available, you can use it as a reference. So I just downloaded the task of PyTest and it's in my Kubernetes cluster. I can reference it and use it in my pipeline. Okay, all right. So this is one of the screenshots for my operator pipeline where we have a set of environment setup, then we have a provisioning area where we provision multiple bare metal machines and deploy Kubernetes cluster on it using CRC and kind. We the Git event actions which we trigger on the GitHub side. We wait for the polling agent to get the information from the GitHub side, and then we execute multiple tests in parallel, which is from the UI, backend, DB, and the API side. Finally, we submit the test run, and after that, we can get the notification of completion. Well, this is the demo for how you can execute a pipeline from the CLI as well as from the UI. So this is a simple example of running your CI pipeline using the Tecton CLI. You can use overriding your default parameters, as well as if you want to use the existing default parameters, you can use set params default. Once you run it from there, it's pretty easy that it gets executed on the UI side. You can also redirect these logs from the terminal, as well as you can see on the OpenShift side under the task logs. So, all right. Sorry. So that was an example of how we trigger the test from the CLI. Also, you can directly trigger tests from the UI side. It depends on like what's the demand for execution of your test frequency. So you can directly go and override the variables from there, and you can execute the test. All right. For test logging and notification, we are using Report Portal, where we are pushing all our test results into the launches. So it supports the launches format where you have all the test results from multiple sources. You can also see and configure your customized dashboards based out of which you can understand what is the failure analysis for your entire test suite and for that program. The notification part consists of custom messages that we are sending on the Google Chat side, which gives the information from the Tecton logs, as well as from the test results. So we customize our notification format. Well, this is an example like how does the report portal analysis looks like. You have your test results over here. You can see the test logs published. It also has the capability of predicting the failure. So it saves a lot of our time in identifying like what was the reason of failure. So let's say if there's a system related issue, if it's a product related issue, or it's an automation bug. So we can just identify from this test log analysis, and it's automatically reflects with all these kinds of defect types. So rather than investing times,
Actually, your room is until 5 o'clock.
Okay.
6 o'clock, I got another event coming. I no time to do. Sorry, you
Okay.
can close up.
All right, I'll just hurry up. All right, so you can see the dashboard over here, which has the predictions of the test run, and also you can see the Git chat notifications, which we have customized, has information of the Tecton logs. You can directly navigate Tecton dashboard as well as report portal log instance from here. All right. I think I won't be taking much of the time. So these are the resources and the reference which you can refer for Tecton OpenShift pipelines. We have our project operator pipelines hosted in GitHub, from where you can take a reference of it. Also, there are different tutorials on the Jenkins and other CI tools like GitHub Actions. You can just refer it. All right, thank you. Thank you everyone for being so patient. I thought I covered the talk on time.
Let's thank the speaker. We don't have time. One short question. If anyone has one, please no long one. That takes offline for tomorrow. So you are completely on time. I'm not sure what happened here. So don't worry about this. But I mean, the 50 minutes are over. Okay. Well then, thanks everyone for joining. Let's give our speaker.
Thank you everyone.
So our program here is finished. We will have more sessions. We have tonight.